All right, so next up, we're going to look at a mixing problem. So I'd like you to take just a minute to read this over, please. Okay, and so we've been practicing setting these up, and one of your jobs in the worksheet is going to be to build a model that has some of these different parameters left just as parameters instead of us like recalculating each time. But in this problem, we're just going to set this up. We're going to build our DE and solve it, and then answer some questions about our model. So let's take a look. So we have this tank that has a capacity of 500 gallons. And we are starting with 400 gallons of solution. And the concentration of the solution is equal to 1 pound per gallon at the start. All right, at time 0, we're going to be adding in a solution with a concentration of 2 pounds per gallon at a rate of 7 gallons per minute. And at the same time, we are letting our tank drain, where we have a well-mixed solution at a concentration that we're going to find, leaving at a rate of 3 gallons per minute. And so we want to build an initial value problem that describes this tank. We're going to this time, we're going to find a solution that describes the pounds of salt in our tank at time t. And we're going to look at the concentration of salt in the tank at the time that the tank actually fills up. So let's write down a couple of variable names. So S of t is going to be the pounds of salt in the tank at time t. We have a little bit of information here. We know that S at 0 is equal to 400 gallons times 1 pound per gallon, or we start with 400 pounds of salts in our tank. Okay, our principle that we're using is that our rate of change of the pounds of salt, so pounds per minute, is given as the rate in pounds per minute minus the rate out. Okay, so as we set this up, our rate in is given by what's coming in. We have 7 gallons per minute, and each gallon contains 2 pounds worth of salt dissolved in it. So we have 2 pounds per gallon times 7 gallons per minute. And if we take a look at this, our gallons cancel out and we're left with pounds per minute. When we look at our rate out, we're going to build it in the same way. So first we're going to find our concentration. The total pounds of salt in our tank is given by S. The total gallons, we start with 400. And if we take a look at the gallons in and the gallons out, we see that the net change in gallons, that rate of the fluid flowing, is going to be that we gain 4 gallons per minute in our tank. So this is given by S over 400 plus 4 times T. Pounds per gallon. And we're multiplying this by our rate out, our fluid rate out, which is 3 gallons per minute. Our gallons cancel out. And what we're left with is ds dt is 14 pounds per minute minus 3s over 400 plus 4t. with an initial amount of salt of 400 pounds. So we had practiced building these DEs before. Now we're going to solve it. If we look at this expression, we can see it's linear. So let's put it into the standard form, and then we're going to solve it. So we get ds dt plus 3 over 400 plus 4t times s equals 14. So here, that coefficient of s is given by 3 over 400 plus 4t. So our integrating factor, mu of t, is going to be e to the integral of 3 over 400 plus 4t dt. And this is just a little u sub. We're going to let u be equal to 400 plus 4t. And our du be equal to 4 dt. So this will be e to the 3/4 the integral 1 over u du. And now that is an integral that we know. That's just the natural log of u. So we have e to the 3/4 natural log of 400 plus 4t. Okay, now before we can simplify this, we have this 3/4 that is in the way, right? E to the natural log, these functions are inverses of each other. But when we have that coefficient of 3/4, we can't apply this inverse property. So we have two options. We can either bring this 3/4 up into the natural log as a power, or consider doing e to the natural log of 400 plus 4t all to the 3/4 power. Now that exponential and the natural log cancel out, and we're left with 400 plus 4t to the 3/4 power. So this guy is our integrating factor. We're going to multiply both sides of our equation by this integrating factor. On the left, we have the derivative of s times 400 plus 4t to the 3/4. On the right, we have 14 times 400 plus 4t to the 3/4. And so we're going to integrate both sides, and we get s times 400 plus 4t to the 3/4. The right side integral, again, we can use just a little u substitution to do this. Let's write it out. So we're integrating 14 times 400 plus 4t to the 3/4. Okay. Our u is going to be 400 plus 4t. Du is 4 dt. So we end up with 14 over 4 times this integral of u to the 3/4 u. Okay, we integrate this by adding 1. So that was 7/2 times u to the 7/4. And we want to divide by 7/4, or i.e. multiply by 4/7. Our 7's cancel out, and we're left with 2 u to the 7/4. So let's simplify this a little bit. We have s times 400 plus 4t to the 3/4 is equal to 2 times 400 plus 4t to the 7/4. This is all plus c. Okay. Now we're going to solve for s. So we divide both sides, and we get t times 400 plus 4t plus c over 400 plus 4t to the 3/4. Okay. So this is our general solution. Next up, we have our initial condition that we are trying to match. So we know that S at 0 is equal to 400. All right, so we're going to find our value for C. So we get 400 is 2 times 400 plus C over 400 to the 3/4. And then subtracting across, we get negative 400 equals C over 400 to the 3/4. Okay. All right, now we can solve for C. And this gives us negative 400 to the 7/4. All righty. Now, we can either leave our answer exact in this way. So 800, I like it in this format. So 2 times 400 plus 40 minus 400 to the 7/4. Oops, oops, come back. Minus 400 to the 7/4, all over 400 plus 40 to the 3/4. Or if we wish to, we can say this is approximately equal to 2 times 400 plus 40 minus 35,780 over 400 plus 40 to the 3/4. Alrighty. Okay, now our question was, what should our concentration be when our tank fills up? So let's first figure out, when does our tank fill up? So we had a let's go back to our problem. We had a 500-gallon tank. We started with 400 gallons. And our rate of adding solution is 7 gallons per minute. Our rate of losing it is 3 gallons per minute. So we have 500 equals 400 plus 4t. So 100, oopsie, 100 is 4t. And so the time to fill is going to be 25 minutes. Okay. All right, so to find this concentration, we know the gallons that we're going to have 500 gallons, but we need to know that that the amount of salt at time 25, which we will divide through by 500. Okay. All right, so let's take a look. We're just going to plug in 25 in for t to find this value. Okay, so we evaluate S at 25. If we're using the exact form, we have 2 times 500 minus 400 to the 7/4 over 500 to the 3/4, and then the whole thing is divided by 500. Okay, so let's check this out. And calculating this, I get about 1.32 pounds per gallon. Okay, if we take a look at what we started with, our initial concentration was 1 pound per gallon, and then we're adding in this new concentration of 2 pounds per gallon. And so we expect to see something in between 1 and 2. We would need a bigger tank for our total concentration to approach the concentration of the added solution. Okay. All right. That's it, folks.